everybody. I'm Leyla Askerli, a freshman IT student and at the same time a team leader of team number 56. I've constructed OrGate and prepared lab reports for this task.
Hi everyone, my full name is Sinzade Shams. I'm a math student. I'm a member of Team 56. I have constructed a node gate and assisted our team leader in preparing a lab report.
Hi, I am Sadi. My field is computer science. I am member of the 56 team and I made the OrGate, and also I am the one of the editors of this video.
Hello, my name is Mehmet Muhammad. I'm a student of Information Technologies and I'm from Team 56. I did the job of editors in this lab and as well as the AND gate. So this is the cat of our team.
A few moments later.
In the NOT gate circuit, first of all, Shams placed a push button and then connected an LED. After that, she connected one side of the wire to the button and the other side to the positive terminal. Next, she added two resistors, one with a resistance of 2000 ohms and another with 330 ohms. The 2000 ohm resistor was connected to the base of the transistor. It was chosen because the base requires only a small current and a high resistance helps limit the current passing through the button. Then the 330 ohm resistor was connected to protect the LED from excessive current. After that, Shams connected the transistor. One wire was connected from the positive side of the LED, the 330 ohm resistor, and another wire from the resistor to the collector of the transistor. The negative side of the LED was connected to the ground, the negative terminal. The emitter of the transistor was also linked to the negative side of the circuit. Actually, the red wire represents the positive side and the blue one represents the negative side. During the process, my groupmate changed the wire that connected the LED to the negative side, moving it from the right side of the board to the left side because the right side circuit didn't work properly. Finally, when the circuit was powered and the button was pressed, the NOT gate worked properly. In the AND gate circuit, Muhammad placed two transistors first. He connected a wire from the emitter of the first transistor to the negative terminal. The first transistor was placed on the right side. Then he added a 2000 ohm resistor to the base of this transistor. Next, he used a wire to connect the collector of the first transistor to the emitter of the second transistor, which was in the middle. Another 2000 ohm resistor was connected to the base of the second transistor. After that, he connected two push buttons, each one linked to a 2000 ohm resistor in sequence. Then he added the third transistor and used the wire to connect its emitter to the negative terminal. He also connected the second button to the positive terminal using a wire and did the same thing the same with the first button. Then he added one more 2000 ohm resistor and connected it with a wire to the collector of the second transistor. Another wire was used to connect the base of the third transistor to this resistor. After that, he connected an LED and added a 330 ohm resistor to protect it from excessive current. The positive side of LED was linked to the 330 ohm resistor and the negative side was connected to the negative terminal. Finally, the last wire connected the collector of the third transistor to the 330 ohm resistor. When the AND gate was powered and both buttons were pressed at the same time, the LED turned on, meaning that the circuit worked correctly.
I gotta tell you, it was perfect. Perfect. Everything, down to the last minute details.
In our gate, first I placed a 330 ohm resistor, then a 2000 ohm resistor. After that, I added the LED and connected two transistors. One of the transistors was positioned lower than the others. Then I used the wire to connect the positive terminal of the LED to the 330 ohm resistor. And after that, I connected another transistor so that I had two transistors on the same level and one below. Then I used the wire to connect the 330 ohm resistor to the collector of the first transistor on the right. Next, I used another wire to connect the base of that same transistor to the 2000 ohm resistor. After that, I linked the 2000 ohm resistor to the collector of the first transistor on the left. I added another wire to connect the 2000 ohm resistor to the collector of the middle transistor. Then I connected the 2000 ohm resistors to the middle transistor and the first one on the left, and linked the transistors to the bases of the others. After that, I connected the buttons to the resistors that were previously attached to the 2000 ohm resistor. Then I used two wires to connect the buttons to the positive terminal. We also used a wire to connect the negative leg of the LED to the negative terminal. After that, I placed three wires to connect the emitters of each transistor to the negative terminal. However, the OR gate didn't work. To be honest, we didn't understand why this gate didn't work. We tried to find the mistake, but as the time passed quickly and we couldn't find anything, we decided to remove all the wires and start the circuit again from scratch. The second time, we tried to be more careful and looked at each of the wires more detailedly in order to not make any mistakes. So in the end, we managed to finish this OR gate and connected it to the power. We charged it, and finally the OR gate worked successfully. And when we pressed one button, the LED turned on. Then we tried to press both buttons of the mechanism of the OR logic gate at the same time, and the LED turned on. So the gate was finished and constructed successfully.